Yo, I'm back. I had forgotten to put this question on the review, so I paused the video, and oh my god. Sorry, I almost just knocked over my monster. Um, Here's the second part of module 2. All right, we've got another equation that we want to graph, and we are going to do it the same way, very systematically. Once I get my standard equation, let me make this red. Once we get my standard equation, I'm going to immediately fill in the y-intercept, which is just the b. Was this 10 or 8? It was 10. And sorry, the y-intercept is just the c. So it's y-intercepts are when x equals 0, right? So if I plug in x for 0, these go away, and we're left with 24. All right, factored form time. We want to find two numbers that multiply to positive 24 and add to negative 10. Off to the side, I'm going to list all my ways to multiply to 24. I've got 1 times 24, 2 times 12, 3 times 8, 4 times 6. 5 does not work. 6 has already been used. So if we had written out more numbers, we just cross them out. And then I remember, oh wait, hold on. None of these actually multiply, or all of these multiply to 24, but none of them will add to negative 10, right? I would need to make both numbers, both factor pairs, negative. Because now I've got things that multiply to positive 24, but also will add up to a negative number. So let's go through that. That adds to negative 25, that adds to negative 14, this adds to negative 11. Negative 4 and negative 6 are my winners. So I think the factored form is minus 4 and minus 6. Over here I'm going to write this minus 4 minus 6. And this standard form, or sorry, this factored form gives me my x-intercepts. And we change the sign because, again, we're trying to find things that when we plug it in, it actually gives me 0. Vertex form. We start with standard form. We divide b by 2. We say, wow, if that was a perfect square, this part would have given me x squared minus 10x plus 25. But I actually want to subtract it by 1 so that it matches with my original equation, which is the 24. So I think I've got my vertex form as well. This tells me my vertex and my line of symmetry. Now that I have these three things, my key features, I bring them up to my graph, I graph some axes, and I start plugging stuff in. So my x-intercept is 4 and 6. My vertex is 5, negative 1. My y-intercept is going to be too high up on the graph to chart, so I'm instead going to find my 5 points by going up 1 over 1, again, up 1 squared, over 2, up 2 squared, over 3, up 3 squared, and then as artfully as possible, connect my line into a parabola. All right. The very last question is one I actually do want to go over quite a lot. It's a word problem. It's going to tell you a scenario like that I'm throwing a ball off a cliff, or that I'm making a pizza, or that I'm watching students throw their phone into the air for the TikTok trend last year, whatever it is, right? It's going to be some sort of projectile motion, which is when we're throwing something, we're standing not at the ground level, but like holding something not at ground level, throwing it up, and then watching it fall to the ground. So again, it goes up and then falls to the ground. This is a quadratic equation. When you model the height as h and you're plugging in like seconds or minutes or whatever. So, our scenario is I'm watching students throw their cameras into the air for some new TikTok trend, and I decide that instead of stopping them, I'll model their behavior with a quadratic equation. That sounds like me. I decide that t is time in seconds and h is time in feet, and now, or height in feet, and we're ready to go. I have given you all the versions of this equation, right? So I actually think that we know the y-intercept is 4. I think that we know the x-intercepts are the negative version of what I just underlined in blue. And I think I know the vertex is 0.45578. Again, the negative version of negative 0.45 and 578 vertex. I also think that 4 and 578 are heights because they are not in parentheses. They are the y stuff. They're how far up and down we move on the graph. And then I think that we know, oh my gosh, that these numbers are time. Because they're in parentheses, they end up being x values, like the x value of the vertex or the x-intercepts. So I think we can answer all these questions I'm about to ask without doing any computation. I don't need to factor anything. I don't need to, complete the square. I don't need to use the quadratic equation or whatever. I actually already have all the information I need to just answer these questions. Let's try it out. How high are they throwing their phones? What is the maximum height and how long does it take to reach there? When we're talking about maximum height, this is the vertex. So I should use vertex form because that's the one that already shows me the vertex. No math or no computational math needed, just interpretation, right? The feet is the y value and the seconds is the x value of the vertex. Question B, how tall is the student I'm modeling? Their height is the initial height of the phone, or at least I'm pretending it is. My model isn't perfect. Which equation shows me this without having to do any computations, right? If I'm looking for initial height, so like y value, because height is the y value at the very beginning, this is the y-intercept. So I'm going to look at standard form and just write 4 feet. And then, oh no, they've dropped their phone. Who could have predicted this entirely predictable scenario, right? Let me draw a line. It's going to bother me. There we go. And, oh no, they dropped their phone. How many seconds did it take for the phone to hit the floor, which is at h equals 0? If you're hitting the floor, this is basically the x-axis. So these are the x-intercepts, right? So factored form gives me this information for free. And I think factored form has told me that this is either negative 0.36 or positive 1.25. If I'm looking for seconds, I'm going to go with positive 1.25. So again, when you get this projectile motion thing, we don't really need to do any math work per se. We just need to do a lot of math thinking. We need to say, all the information is already here. All of my numbers are already solved for. I might have to switch a sign. Like I might have to make something positive or negative. Make something positive. But I don't need to use like the quadratic equation or anything. So the questions are asking, A, what's the answer? And B, which equation did you look at to find this answer? Okay, follow for more fun facts about math, I guess. I'll see you on the video for Module 3.